Hey everyone, in this last content video for our sequels in the series, we're looking at convergence and divergence, an idea that we've actually previously explored in our sum to infinity video, but now we'll look at it in a more general sense and not just apply it in our sum to infinity. Alright. Now the whole idea of convergence and divergence is about looking at how a function, let's say we have fn or un, alright, behaves when in the long run, right? So how this function, whether it's a fn or un, behaves in the long run. So in mathematics, right, what does it mean for a function to behave in the long run? What is the long run? So the long run, basically the idea of infinity, right? It's basically the idea of infinity, where we have one variable that approaches infinity, and how does this variable approach infinity affect the function, all right? So let's say we have fn and un. The variable that we will be looking at would be n, right? So how does this function behave as n approaches infinity, all right? Another way to look at it is basically how does the limit of fn or un, what is the limit of fn and un as n approaches infinity, all right? So the idea is that you want to set n approaches infinity, and what would happen to fn and un? The idea that whether does this function have a limit as n approaches infinity. So does this have a limit L, because limit is L, or not have a limit L? Or in some cases, right, we have two limits, but it's sometimes oscillating, right? For example, let's say you have sine pi, no, not sine pi, sorry, sine 3 pi over 2n, right? You notice that this value is either 1 or minus 1, all right? So in this case, it's neither diverging nor converging. But if you look at the first two, right, which is actually what we are interested in, if you look at the first one, if there is a limit, then this would be converging, all right? If there is no limit at all, it is diverging. If it's the third case, then, well, it really depends. It could be oscillating, it could be many different things, all right? But basically, the idea is that this one is neither converge nor diverge, all right? So just for information for the third one. But we are only interested in the first two for this video, so let's just explore this two in the first. Let's explore this two in more in depth, all right? So how do we apply the idea of convergence and divergence in our questions, all right, in our examples? So let's take a look at the example that we've used in our method of difference. The example on, let's say if r equals to 2 summation to n of 1 over r times r minus 1, all right? So basically, on top of my head, I know that the summation is basically 1 minus 1 over n, right? Just apply your MOD, and there you have it. Now, if you want to see whether this summation has a limit, what do we do? The idea is long run, therefore n approaches infinity. So what we can express this as, right? So limit as n approaches infinity, limit of this summation, and r equals to 2, 1 over r minus 1. And the idea is that basically, now you apply n approaches infinity, and then find out what would happen to the individual terms that contain n when n gets larger and larger, all right? So let's look at the first term, okay? So the first term is just 1, right? There's no n, so therefore, you just simply be 1. Now we look at the next term, which is minus 1 over n. So as n approaches infinity, 1 divided by a very large number, we know it's going to be very small. As n gets even larger, it gets smaller and smaller, but it's never negative, right? 1 over n is never negative, okay? Because 1 divided by a positive number would never be negative. But you'll get very, very, very small, and therefore get very close to 0. So what we can do is, to find this, right, we know that as n approaches infinity, 1 over n approaches 0. So what happens is that we'll get 1 minus 0, and therefore we get 1 back. And as such, the limit of this summation as n approaches infinity would simply be 1. Another way to actually express this only for our summation is we can actually express this as a summation of r equals to 2, the lower limit is the same, and to infinity 1 over r minus 1. Basically, this is also a summation to infinity, all right? Just that it's not like the summation of infinity in your geometric progression, all right? Same idea, basically adding infinite number of terms and what would happen. All right. If not, generally this would be the generic form. It's basically the idea of convergence and divergence would be, let's say, limit of n of infinity of your fn or un. All right. This would be the generic form. All right. Alternatively, you will see something like u infinity or s infinity. All right. So it's also the same thing, basically putting n to infinity. All right. Let's look at another example where, let's say, fn, a very simple one, is 1 plus n. All right. And we know that, let's say we're going to find the limit of n approaches infinity. All right. So the limit of fn as n approaches infinity, we know is going to be infinity, right? Because infinity plus 1 is basically infinity. Therefore, we know that this is diverging. All right. And for the one above, we know that this will be converging because a limit exists as n approaches infinity, whereas for fn equals to 1 plus n, there is no limit. All right. And therefore, diverging. All right. So there we have it, the idea of convergence and divergence, where we're looking at the long run and we're looking at a variable that approaches infinity.